на английски си продължам. Окей? Добро. Jaz sem Angel in sem iOS developer backend período. E sem del od startup ще вика Augmented, доста сме нови. И генерално сме фокусирани на развой на AR технологии и VR технологии, общо се ще е повързано с Augmented Reality. И now switch to English. So basically the motivation for today's presentation was to go over what's possible in to do in AR on an iPhone, given with the changes that we have coming the past 6 months, that being the Vision OS and the Vision Pro. Hopefully this will be a bit of an introduction for everyone how to get started with augmented reality and virtual reality on iOS. Hopefully we can turn this into a series and dive a bit deeper in some of the next presentations. So, what's the timeline of AR development on the iPhone? So, when I started working with iOS and typing any kind of iOS code, the iPhone of the day was that little gray box that you see in the corner there, which was the iPhone 6. And basically, it had a single camera on the front, a single camera on the back. And it was at that time that Apple introduced a library that's called Augmented ARKit. And it was a groundbreaking library that allowed users to overlay any kind of 3D models, 3D renderings onto the real world. And then a few years later, iPhones got a second camera. So the significance of that is that we finally had 2 images and we could extract some kind of a depth map of the world, further improving the AR experience. And then a bit further along, like phones got a third camera, but more importantly, they got a sensor on the front that was called the true depth sensor, which allowed a far more finite analysis of depth and scanning. And then the final step that we have is the LiDAR sensor, which we got for the first time on the iPad, and a new framework that came with it that was called RealityKit. So this was quite a big jump for the AR world because of how significant LiDAR is and what it does. We'll cover some of the topics in the next few slides. So what can you do on iOS with augmented reality today? So you have 2 libraries that are available to you. That's ARKit, the one that I mentioned first, and then we have RealityKit. ARKit focuses a bit more on world tracking and observation and classification of the world, sort of doing the math of your surrounding and providing it for you. RealityKit, you can think of this library as working on top of ARKit, and it handles all the renderings, the complicated stuff like collisions, occlusions, and materials, as well as one very big advantage, and that is the interaction with the 3D element that you overlay in your app. When it comes to ARKit, you have two options that you can use to render your 3D models, basically like an engine. SpriteKit if you want to use 2D models, and for 2D and for 3D models and geometries you have SyncKit. Or if you want to develop your own engine, you can go over to MetalKit. A good mention here is the Vision OS. So we have a lot of advantages that have been imported from there into the ARKit and RealityKit libraries, although that can be a presentation for another time. And I honestly could not leave Unity out. Unity is a very powerful engine for computer graphics, for 3D animation, as well as for augmented reality. In fact, I believe most of the 3D graphics that you see on your phone, be it a game or an AR experience, usually are done in Unity. And even so that with the Vision Pro, they couldn't leave it out, and they have a very big cooperation. Before we dive into each of the libraries, we can go over some of the jargon that we're going to use here when we talk about augmented reality. So the first thing here on the list is something called features. And some and different, you can find these names differently in different literatures and maybe different technologies. However, basically what this means is as soon as the AR session starts, your phone focuses on different contrast elements in your world to find any characteristics that it could compare and determine where you are in the real world. I don't know if this is still true, but when ARKit came out, it used an algorithm that using the gyroscope and the accelerometer of the iPhone, it took a certain amount of pictures per second, and it compared the differences that it found in each of the images that it took, so to create an experience of moving the 3D content inside the real world. The next and features, you can see them here on the photo with the gray bedding, so you can see wherever we have a contrast differences in the image, we can see many feature points that are being detected. The second point that I want to mention is planes. Planes were and still are a very big and important thing in augmented reality. But when ARKit came out, basically it was the thing you had to do. That's how the AR session started. However, this is not necessarily the case anymore. So these are any horizontal or vertical surfaces where your 3D content could be laid over. Finally, we have anchors. And anchors are also a very important part of the AR machinery that drives your AR experience. And these are basically they're invisible tracks elements into your world that usually are used to lay over your 3D elements on. So if you see the image that's labeled anchors, you can see that we have a few elements on it. We have these small yellow dots which symbolize the features that we find. And then we have these 3 lines, which are basically the center of the coordinate system of the AR session. And the small little red box on the bottom is actually the anchor of the plane that was found. So here we see a center of the world that is located somewhere in the camera. And we have the plane detection on the tiles on the bottom and the entire AR anchor plane placed over it, which then can be used to lay over items on it. Nodes and entities are 2 separate words that are coming from ARKit and RealityKit. So ARKit relies on something called nodes, which usually are used to represent some of the 3D geometry that we are going to lay over the AR session, and they are usually attached to the anchors. Entities, on the other hand, also represent the 3D geometry. However, they are a bit of a different kind of a thing in RealityKit, and we'll go over them a bit later. Finally, probably the most important part is the meshes that we generate during an AR session, or just a mesh of an item. You can think of these are sort of the scaffolding. So any graphics that we overlay onto our AR session will probably have a mesh. Usually whenever we start with a AR session, for example, maybe it could be a LiDAR-enabled device, the phone immediately starts to create a mesh of the environments that it surrounds. Okay, so we can start with ARKit and see what it does and what it's capable of. So as I said, ARKit is sort of the world tracking part of the reality of the augmented reality toolset on iOS. So we usually, unfortunately, even now it's still UIKit based. What you usually get is some kind of an AR session that is initialized with a configuration. So this configuration can usually be configured on with many things depending on what we want this session to return to us. And most of the time, this is some kind of a basic world tracking configuration where we want to track the horizontal or vertical planes of our world. However, these can be combined with the RealityKit, and we can really leverage a lot of the data that it returns for us. And usually that data is present in something called an augmented reality frame or AR frame. And AR frames are usually returned to us depending on the quality of the session. Usually we can configure this, but optimally we want to get 60 frames per second. And this is where we usually access most of the data that's available that ARKit has detected from the world. When ARKit was starting, a way to interact with the observe the world was using something called a hit test. Fortunately, this is deprecated, and a different method is now used. So on the picture here, you can see an app that's configured with a world tracking configuration to track horizontal and vertical planes. And as soon as the planes are, as soon as the anchor for the planes is set, we're doing some kind of a visualization where we overlay the detected plane with some kind of a node that contains a graphic which forms the texture that we see here. So let's say we've started our app, we're detecting the planes, and we want to place some kind of an item, some kind of an asset, and a 3D asset that we have. In our case, it can be this teapot. So you can see here the configuration of the session being created as soon as the view loads. This is a UIKit lifecycle methods for everyone that has not developed in UIKit. Here we set a few of the debugging options that we want to see from the session. We want to see maybe some of the feature points and the world origin so that we can understand better how our items are placed in the session. And we set something called a delegate method that we will cover later. Picking a place where we want to place the object, we just tap on the screen, and what happens is a raycast is being cast. So as I said, no longer a hit test. What's a raycast? Raycast is basically kind of what it explains in its name. A ray is being cast onto the real world, and some kind of a position is returned to us where it intersects with that ray. So here we're saying do a raycast, but allow only planes that you found on the surfaces and make sure that they are horizontal. So as soon as we tap on the screen, the location from our scene view, in this case we're using SceneKit that I forgot to mention, we are trying to scale that location into view and performing a raycast. Results are returned depending of if any planes were actually intersecting with our raycast, and if they are being placed. We call a function to place our 3D model at that location. So what about the delegation methods that we previously set up? So scene view has a few methods that it has. And the first one is the renderer. So this method is called every time whenever a node has been added or has been found for a certain anchor. And the other methods look pretty much like lifecycle methods. So anytime a node is changed or added or removed, these methods trigger. A sort of limitation, at least for me in ARKit, is that pretty much almost all of the lifecycle of our AR session relies on all of these methods. So here we see the code that we wrote to display to texturize the plane that we are detecting. So you see every time that I see that a node has been updated, meaning the session updated all of the nodes and the anchors that it's observing in the world, I noted the did update function is triggered, and I have to see if the anchor that I have was for a plane. And as soon as it is for a plane, I can call the function to update the visual elements that I have. Yeah, so then after some time, RealityKit came out, which was a great improvement on ARKit, and ARKit is pretty much, I would say, it's still present, and RealityKit still has it inside it. It's also still responsible for almost everything that we get from the real world and all the data that we have. However, for now, RealityKit is the preferred way of starting of doing an AR app. And Also, unfortunately, still UIKit based, although now we do not have to rely on any other engine library like SceneKit or SpriteKit. Here we get a dedicated AR view and interacting with the, while we can still listen on changes on the session, we no longer have to use the lifecycle methods that we had from the scene delegates. As I said before, ARKit relies on something that are called nodes, which are which we usually use from the engine that we're using. In our kit, it was SceneKit. Here, there is something called an entity component system. So this is a very interesting concept from data-driven development, and it's a very famous form of, it's a very famous architecture that's used anywhere in game development, where basically we have no moving logic or any kind of business logic inside the entities. Basically, they are described only by the data that they hold. And you can see that almost any entity almost all of our entities have a synchronization and a transform component. These two components are, transform is used to place this entity into a augmented reality setting, and the synchronization component we use for sessions over the network. As I said, there is a strong focus on rendering here with these components. And what a Reality Kit allows for us out of the box is to extend our entities with physics, materials, and immersion or occlusion out of the box. And it's, as I said, it's currently the recommended way of doing augmented reality on iOS. And it was at this time that raycasting was introduced. So how does it work? We'll go through a small example. Basically, as I said, we no longer need to have SceneKit on it. We can immediately start working with our AR view, and when we decide what we want to do in this augmented reality, it's important to know that we still have inside an AR session with a given configuration. So you will now see a small example of how we're going to create an entity for our world and extend its components extend its components and configure our session. So for this example, we've decided to create a custom AR view. So we can do this by extending the AR view class, and then basically, we are going to use ARKit for the world tracking. I believe in this case, we again have the session set to discover, to estimate planes. And as soon as we do a raycast, basically what we do is, again, we are setting the touch gesture recognizer on our AR view, and as soon as we have a touch, we do a raycast to find an item onto our a plane that's already been detected in the AR view. And whenever we have a returned result, we create an AR anchor for our entity. We add it to our session, and basically at this point in the code, we only have an entity that has a transform and an entity that has a synchronization component. What we want to do is maybe add a bit of a physics component. We do this by adding a physics body, which in our case will be some kind of a box or a cube, depending on the selection. So this was supposed to be a video. What it demonstrates is, you can see after we've added everything to our component, to our entity that we created, if we print out all of the components that it has inside, you can see that it has a physics body, a motion component, and a modal component. What this example demonstrates is a overlaying of basically a box building sets, and then you can interact with them using other air elements and throw them off the plane that we are detecting here. Video after the presentation. Okay, so we saw quite a lot of the, we saw a bit of an interaction now and how items are moved. And I wanted to mention here a very important part that basically augmented reality is 3D development and game development. Also, the world that we see is presented into a coordinate system that's X, Y, Z, and any sort of interaction with it is done using vectors and matrices, which is incredibly hard, and this was the hardest part for me. And you will most likely interact this if you are using maybe something a bit more low level with ARKit. So I recommend sticking with RealityKit and relying on all the methods that are available to you from the entity. So you don't have to directly work with the transforms that are provided to us from the session, which is basically linear algebra. So finally, I want to spend a few minutes talking about LiDAR. So LiDAR is the latest edition done on the iPhone regarding AR and photography and stuff like that. It's quite powerful, and what it does is projects a ray of light onto the world, and then it measures the distance that it takes for the light to be returned to the camera. And with that, it creates something called a depth map. And along with the depth map, it also we are also provided with something called a confidence map, depending on the conditions and the ability to detect this depth map that we can later use. It adds very big. It adds quite a lot of to the quality of the AR session. As you know, previously we relied on basically computer vision to detect features into the settings. Now we have completed generated meshes that are far more precise and plane detection. A very interesting example that we can see using the LiDAR sensor and its data is the scene understanding and 3D objects and identifying of 3D and interacting with 3D objects with LiDAR. So for that, the session for us provides something called a scanning configuration. So as I said, we can configure the AR session to whatever we want to do. So we are no longer using world tracking. We are going to use object scanning configuration. And what we're going to try to do is create something called a reference object of an object that we are seeing. We want to extract the data that we've analyzed for that object and maybe use it to identify the object in our setting. So we configure our AR session, and we will use the margin background function that's used that's available from us from the session. Of course, there's a bit of manual work. This function is called on every frame, so we will be leveraging the session methods from the lifecycle methods from the session. And we'll be using the render function to take every AR frame as often as we can get it. So how do we know that the user is done with the scanning? We'll have to do a bit of manual work and ask the user for input and maybe control somehow the flow of the scanning. So here we see this code in action trying to scan an item. This will be the Apple Magic Mouse. So what we do is we ask the users to set some kind of a boundary, and we will use this boundary to determine that the user is done with scanning. As soon as the boundary is set, we start a scan. And how do we inform the user that we have enough data regarding the object that they are scanning? Basically, in the example, we'll color each of the cubes that we are outlining here. How do we know that we have a complete scan? Well, that will be up to the lifecycle methods, because they will inform us that new anchors were added. So we can estimate how many anchors do we need per side. And when the user is done, we can test out, basically the session will reset, and the user will be asked to scan around. And as you can see in the last photo, the mouse is found on the table and is being identified. Additionally, all of this data with all of its features and anchors can be extracted, and next time that we have another project or another session, we can include it into our asset catalog and basically set it in the detection objects variable of our session. Okay, so basically, I think the total development time of Air on iOS has been sometime since 2017. We are now into the age of spatial computing, whatever that means. However, I still think that the most powerful Air device is still the iPhone in its current state. And almost every of the aspects of how AirKit works, its world tracking, as well as the rendering function of RealityKit can definitely be found in Vision OS and the Vision Pro. A good thing is that finally with Swift UI, you no longer have to put up with UIKit. And yeah, so hopefully next time we'll be able to have a few more examples with the Vision OS and the Vision Pro. Okay, that's all. Thank you. Aha, dobro.
Pa na stream ne mora biti. Aj ги пратиш на слик.
Ајде.
Добро, сајзот на моделите?
Потоците што се собираат се доста големи, во зависност од тоа дали ќе имаат слики во нив или не. Исто, конкретно за оваа препознавањево на виртуелни елементи не се многу големи. Може би не до мегабајт 2 генерално се некои описи во светов.
Препознава?
Да.
Го скенира и после можам да го потребам од друг?
Можеш и во друг, да. Можеш да го вчитуваш буквално како од бандол од асет и на сесијата и го даваш да има овакви detection objects.
А има device limit нешто да ќе треба најнов?
Да имаш лайдар. Да.
Што е од 11 на?
Да. Сите битни работи сложени што се поврзани со observing, мислам оваа со 3D object detection е една. Поинтересна работа што мислам дека сите имаат видено е Rumplan. Генерално целиот тој екстракшн на големина на простора е се преку лайдарот. Ами и тоа исто може да се екстрахира и да се во сите можни 3D формати што постојат на различни апликации или енџини да се користат. Okay.
On your experience, how you are saving in working on these models, how you are saving in what format those models, because I have some experience and we were creating our own models. And what practice do you recommend here? To use the existing data as a wireless model?
So when it comes to this type of 3D object recognition, it generates something called an AR object, and as far as I know, it contains some images and some coordinates in a JSON format. As far as I know, that's not standard. Now my experience here is limited. This year, actually last year in June, what came out was the Reality Composer Pro. And this is usually the place where you would convert some of the Apple generated models into something more abstract that's available for other platforms. Regarding the environment on iOS, USDs and USDZs are the things that's used for models. As for scanned environment data, I'm not really sure.
Okay, one more question. So, for example, when you have a model and you have some surfaces, for example, if I want to produce the same surface and
Okay.
model, is there a chance to save that?
Yes. So what you are, what he is describing is photogrammetry. So that is the process of scanning any virtual object, extracting literally a copy of it, including, I guess you also want a mesh. So basically what you're asking is, you're asking if this is possible. I want a copy of it and I want to extract it. So up to last June, this was very hard to do. And that's a good point that now that you mention, ARKit goes best with some kind of machine learning model. Because extracting all the data and anchors manually from the point clouds is a bit difficult. As I said, the depth map is actually a buffer of bits that you can then work with, although manual work is very hard. And now in June, they released an API called Object Capture. And it works a bit similar like the object recognition. In real time, you can create with the LiDAR sensor a 3D representation of a real world object, and yes, you can export it, including with textures. If you don't have a device that runs iOS 17 with the Object API enabled, Object Capture API enabled, what you have to do is maybe do a scanning of the depth data, extract that. You can also do texture scanning, extract that. However, merging both of those is a bit of a challenge with the older APIs. And the Object Capture API on older devices also allows you to take images with your phone and put them literally in the photo gallery. It still has to be an iPhone, as far as I know. It can be a DSLR also. And then you can use those photos to create 3D models from it, even on your iPhone. Okay.
Okay, one more question. So we are talking before the LiDAR technology. Was some of these kits able to provide some image reconstruction algorithm, for example, when you're recording something to generate a model from that, and later use that model for your needs?
Yes, they do. Both the Reality Kit and the AR Kit offer that. So AR Kit will provide you with the environment data, the depth, the different forms, the generated mesh. Reality Kit will help you generate stuff on it. And I guess you're again asking about the bare bones data that you want. And yeah, it's possible. You can export it in any 3D rendering format that you use.
So the whole image reconstruction thing is done on the kit side, not on your side. You are getting already mesh with the environment.
So actually not. The data is a bit low level. It's a bit of a struggle to completely recreate something. So that's why I said you need to maybe have it prepared in some kind of a 3D rendering asset for you to redraw it. And another thing that's also possible is you can save the whole world. There's a function that's called the AR world geometry. So you can save all the anchors that the session has found and maybe restart it again. So this will bring back all the elements back into the session that you had before.
Okay, and the last one, I promise. So have you done some comparison between the LiDAR deep mesh and the older one? How they are generating? What technology is generating a better deep?
A LiDAR all the way.
Yes. Okay.
I personally have not used. I have used an iPhone that contains no LiDAR sensor for basic geometry. I would say they're similar. Of course, the LiDAR sensor will be faster, but if you want to do physics and collision and interaction with it's called scene understanding, occlusion and lighting, LiDAR is definitely the way to go.
Yes, thank you.
Okay, a bit short for me. Why would you say that the iPhone, it's still the best AR device to use and not the Apple Vision Pro? What's it called?
Because of the current state of use cases, battery life, portability.
Have you had the chance to try the Vision OS?
Yes.
And I mean, have you tried it just to use it, or have you also tried like the development experience for it also?
The development experience, I have to say, not yet, but I have used it extensively, and it shows a lot of promise, a lot of potential. I accept it's a first generation device, while the iPhone is what now? The 16th iPhone version will come out in September. The processor is there, the software is good, and you will find that if you look a bit into Vision OS development and Vision Pro, you will find the same paradigms. The same two libraries are present there.
Okay, thank you, Angel.
Thank you.
Once again, let's hear a round of applause. Sorry for interrupting like this, but we are running short of. We have another presenter, and I think AR by far has been the most presented topic here. And on that note, what hasn't been presented is React Native or cross-platform. Do I hear anybody booing this? No? Okay, Sebastian, let's hear more.
Само като шига микрофон.
Старта на тия ова? Добре,
Да.
а избери се кой десктоп сакаш да го презентираш.
Как си местил?
Не е истата?
Не е истата?
Ай, изключи един десктоп, може? Таки
Айде.
убивам десктоп.
Добре.
Че...
Не го ни покажа втория десен. Како?
Шанаца.
Дам само крајчко за
Не постои втор десктоп.
Да не треба пак од кај мене да идем.
А, ако сакаш ти го пратам видеото.
Како беше тоа? Дисплей, дисплей.
Значи не е кликшер проблема.
Туку екс...
Каде ми?
Mirror, така?
Не, сега гледам.
Аха, окей, да, това бил проблем.
Значи да mirror било.
Как се местил?
Или протни го под мајца, или и закачи го од страна некако.
Не бе, ова да учу.
Чекај.
Не е проблем.
Можевте и на мютова да го правите.
Да?
Да.
Where's the fun?
Live debugging.
Да пробваме дали Keynote работа?
Ајде.
Дали е Keynote окей? Okay. Okay, so today I'm going to be talking about cross-platform development with React Native in 2024. A little bit of a clickbait title. My name is Sebastian. I'm a software engineer at Pixel, and I've been working with React Native for quite some time. So before I get started, I want to ask, has anybody used React Native? Okay, is there anybody who doesn't know what React Native is? No, nobody? Okay, so everybody knows. Before I get started, this is a disclaimer. I'm going to be talking about greenfield React Native applications, which are basically applications that are only made in React Native, not that are integrated in a larger application that's either made with Swift, Kotlin, Java, Objective-C, anything. So I'm going to be, I hope somebody didn't know what React Native is, but yeah, so I'm going to quickly explain what React Native is in simple terms, and from there we're gonna get into the main topic. So before talking about what React Native is, I need to mention what React is. So React is a UI library primarily made for the web. When Meta was developing this in 2013, they made the platform, the rendering layer, platform agnostic. which later on they had an idea, what if we change the rendering layer on the web, it's used React DOM, which translates React to web components. What if we change that to something on the native side, on iOS and on Android, which is basically the app registry. So in simpler terms, we have React on one side, which we have some kind of a React component, usually a basic view, which goes through a middle layer, which we're going to talk about, something called the translation layer, which at the end produces native views with all of their accessibility and everything. So at the end, you get an Android view on the Android side, and you get a UI view on the iOS side. In more complicated terms, the basic current architecture of React Native looks something like this. So we have on the two threads basically, a JavaScript thread and a native thread, which they communicate through a bridge, which the bridge currently works something like a REST API, which basically sends serialized JSON from the native to the JS side and from the JS side to the native thread. Now, when React Native came out, they started with JS with JavaScript core, which was the base engine. They've replaced that with RMS, which I'm going to talk about later. So this is the basic stuff of React Native that hopefully you've probably heard of. So let's see what's actually new in the ecosystem, what's actually improved, and see how things have changed. So one of the things that's actually new is basically full TypeScript support, both from the React Native team and the community adoption. So previously there was kind of confusion because Meta internally uses Flow to develop React Native applications, and most of the other side of the world uses TypeScript for static type checking in JavaScript. So from 0.71, they've made it the default preset uses TypeScript, and the types for the library are basically shipped with React Native instead of the types package from NPM. The next big thing that they've released, I think in 2021, it's something called RMS, which is basically a new JavaScript engine optimized specifically for React Native, which previously, as I said, there was something called JavaScript Core, which is shipped with both platforms, either Android or iOS. This had a lot of problems and isn't really optimized for mobile applications. So Meta developed RMS, which basically kind of rearranges the JavaScript pipeline, which we're going to see right now. So this is the JavaScript pipeline that you get from a bundled JS source to executable bytecode. In JSC world, this is the pipeline. So at build time, there's the source. It gets transpiled to a minified bundle. And most of the heavy lifting happens at runtime. This on iOS isn't really much of a problem, but on lower-end Android devices, the slow time, the start times of an application and the time to interact were very, very slow, up to 40 seconds. So RMS basically rearranged some of the stuff. In simplified terms, basically the parsing of the functions, the compilation of the bytecode, and the optimization happens at build time, and at runtime, the owning of the bytecode and the execution of the bytecode gets run at runtime. So I think there is a demo. Okay, no, this is a performance overview. So these are basically the increases that RMS brings to React Native. This is, you don't have to do anything, you just have to swap out the engine. This is out of the box. This is, I think, on the next slide, yeah, there is a video. I think it should start. Yeah. This is on an iPhone 6. So basically, this is the start time. On the left is RMS. On the right side is JSC. The next big thing which Meta has been developing is something called the new architecture, which I just talked about the old architecture. This is basically the future of React Native. And as you can see, they replaced the main problem with React Native, which was the bridge. Basically the translation, the serialized JSON sending between the threads. So what they've done is basically replace the bridge with something called JSI, which is a very fast C++ interface, which allows you to send host objects between the native side and the JS side. And they've also, with the introduction of and the larger usage of static types, through code generation, you can basically generate the native modules or the types that you want to use. So that is how it is defined. Why this was introduced, I'm going to give an example of why the bridge was basically replaced. In the old architecture, let's say you want to send a 60 FPS video through the bridge that gets analyzed on the JS side. So because of, one frame of an iPhone 13 camera is basically up to 3 megabytes. If you send something like 60 FPS, that is a lot of data that gets serialized and then deserialized through the bridge, which means that one thread basically gets blocked. So something like that would be impossible. With the new architecture, you can basically directly access the video side on the native thread through the JSI with turbo modules, which are the new native module replacement. And there is a new rendering layer, which is called Fabric, which basically lets you also access the views through the JSI. Probably the biggest thing that's happened to React Native is something called Expo, which we're going to demo later, which is basically a framework on top of the framework, which basically has created a module system, which lets you write native modules very easily. We're going to see how the code looks for that. So Expo is made out of 3 building blocks. The main one is the Expo modules, which, one thing I forgot to say, the new architecture currently doesn't have Swift support. So you cannot write Swift, it's only Objective-C. What Expo modules does is an abstraction layer on top of the JSI, which lets you write Swift and Kotlin. Kotlin is supported on the new architecture. So to demonstrate this, we're going to write a simple module on the native side, which we're basically going to open a web view, load the web view on the native side, and create a view on the JS side. So let's see how we do that. So the first thing that we need to do is create an Expo module. This is already in an existing Expo project. You can either use local or not local as a parameter. Local means that it's already in a project, which creates a modules folder. So firstly, we need to define on the TypeScript side, we need to define the props that we're going to use and the native view. We're going to call it custom web view, whatever. And currently the props are basically just all of the view props that React Native already gives you to access, to give to views on the native side. So basically, we're going to give 2 props. We're going to give an onload event, which basically tells that the page is loaded, and a URL to send. This is it basically on the TypeScript side. We just tell the props and the native view, and then we can focus on the Swift side. I'm only going to show the Swift code, but it's basically very similar on the Kotlin side. So first thing what we need to do is the CLI through Expo generates 2 Swift files. One of them is a module definition, and the other one is the actual view. So firstly, we need to define the module, which currently we have the name of the module that we're going to use, and the view, which loads the custom web view, which is actual view file. And in the view, we need to define the props, which currently we have one URL and an event on load. These, by the way, the prop, the event, the view, the name, are all helper functions from the Expo modules core. They have great documentation on this. If you want, you can check it out. So how does the view basically works. So there is no support for Swift UI yet. They said that they will add Swift UI, but now you can use it through a UI hosting controller. So you can basically load Swift UIs inside of this. We just load a web view, we init and add it to the subview. This extends from the Expo view, which is a must on the Android side. On iOS, we don't really need to use it. And then we need to mount the frame to the Expo view, so we can add styles from the React side. And we need to actually handle the onload event, which we need to send it to the React side with a delegation. Okay, so this is we need to export our TypeScript props and everything so we can use it in our main project. So basically, this is the web view. This is currently gonna give something like this, which is, by the way, you can buy cards for iOS Conf right now. Yeah. So this is basically, I don't know if the video started. I think it should have. I just basically scroll through it. This is just a web view loaded with nothing else. So we can add we can prettify this. We can basically I'm gonna make a very simple browser with text input. So we're gonna add a safe area with some styles. We're gonna add a few states, which is it loading, the input URL and the URL. This is all styles for the text input. This is a loading component, which basically just activates an activity indicator, and this is the whole app. And we just want to replace if anything starts with HTTP. Okay, so this is how it looks. It's nothing complicated, but I wanted to show how easy it is to actually write a native module. So this is a video. I think I'd just go to Google and yeah. I think I load Facebook as well. I don't know. Yeah, okay. So the other part of the whole Expo ecosystem is something called Expo Go, which we're gonna demo later. So this is basically an app that kind of simplifies mobile development. So it really gets, it's really easy to get your app started with this. So one of the main things that React Native does is something called over-the-air updates, which by the architecture, as you've seen right now, what we can do is basically change the JS bundle. So we can update the JS bundle, which holds all of the logic for what views get called or what views to show. So we can have that somewhere on a server and basically call it over the air. So what that lets you do is basically you can update your application without going through the App Store, which is one of the main selling points as why would you want to use something like React Native. What Expo does is basically has all of the Expo modules that they've built inside an application on the iOS store and on the Android store. So if you don't need any custom native code, so basically all the Expo modules, which they have a lot, you can basically build a full application with this without writing any custom native code. We're gonna demo this later. The next selling point is something called Expo Application Services, which is basically a cloud service, which is something like Xcode Cloud. They offer a build service, which you can build in the cloud, an auto-submit feature, which you can submit your builds to the both the Play Store and the Android, the Play Store and the App Store, and something called Expo Updates, which is a service that lets you do the over-the-air update as a service. Okay, so let's talk about something that's gonna come to React Native probably this year. Okay, something was flashing. So one of the main things that they demoed last year, or they showed, which is the next version of their JS engine, which is something called static Hermes, which basically means to introduce static, basically would turn JavaScript into a statically typed language. Now, if anybody's worked with TypeScript, you know that TypeScript basically is kind of a linter. So you can define the type, but at runtime, the type can be anything. Right, so what static Hermes would basically do is enforce the types. So we have a function here in TypeScript, something subtract. So we have X number, Y number, we subtract them, and we have a list, which has 3 elements. So if we call this function in TypeScript with 10th and 11th element, we would basically get undefined minus undefined. This is a JavaScript exclusive feature. It doesn't work in any other language. So basically what static Hermes would do, it would throw a range error, which doesn't really happen in JS and TypeScript, but this would do that. And yeah, it would basically turn JavaScript into a real language, I guess, not a dynamic language. So what this would enable is directly calling native APIs, as well as the platform integrations, which React Native can be hooked into anything. They can be implemented in the JavaScript, and there will be clear safe and unsafe code distinctions, as well as zero-cost FFI. So I have a demo here, which is basically comparing static Hermes to C. So yeah, this is a very early demo. So this is a demo of something rendering like bunnies on the screen. So this is on an M2 Max. Yeah. It just basically renders 100,000 bunnies. The important thing is the performance here. So this is static Hermes. It's basically a video just rendering this at 100 and something FPS. And this is the C bunny mark performance, which is quite similar. No. It's a little bit better. Let's see a little bit. These are some performances that have been done by the React Native team. So this is basically on par at C level. It's not exactly. So what you can do with this is basically you can basically call native functions from C into your JavaScript. For basic developers, this for us, you know, I don't think that we would probably ever use this, but on an engine level, this would increase the performance by a mile. And yeah, the next thing that I want to talk about is React Forget, which they renamed to Compiler, which is an optimization thing. Or basically, they would add a compiler to the React framework. This is not only for React Native, this is also for React. So in React world, how we optimize our code is basically through 3 hooks, which is one of them is use memo, which basically you can skip the calculation of a value through a re-render using only the dependency array, which is this expensive value here. Use callback is something similar, which basically you can skip the recalculation of a function, which basically returns just a cached version of a function, which basically only gets redone at the dependency array, recalculated. And the last thing is something called memo, which basically you can skip re-renders of a component only when that component's props change. Okay. So this is it of the presentation. The last part I've dedicated to show you some apps that are actually made with React Native. Oh no, I have one. This is the actual performance that the React Forget compiler would bring to React. So this is demo done by Meta at the Quest store, which is basically the store on the VR headset, which is made in React Native. So the green boxes mean that there is re-rendering. The gray boxes mean that there isn't. This is their original optimization. So you can see a lot of it is already some kind partially optimized, but using all of these three hooks, it's very tedious and very time consuming to optimize all of bigger applications. So they're basically doing this to a compiler that is basically going to do it for you. So this is the optimization that they've made, which I think is pretty nice. This will be coming in the next React version, which would probably come by the end of the year, which would mean basically free performance in both web apps and all of the React Native applications that are going to go to the next version. As I said, apps made with React Native. So this is a showcase here. These are some of the applications. So the ones marked with the Expo logo are using the Expo SDK. This doesn't mean that all of them are greenfield applications. So probably like something like Viber Messenger is not entirely made in React Native because it's a really old application, but as it is with Evernote. But I think Discord is primarily made in React Native, and the Xbox and the Game Pass applications. If you want to check out, there is a nice blog post. I've added a QR code to see what applications are actually made with React Native. This is a post by Evan Bacon, which all of the applications that he has posted are from the iOS store. So yeah, okay, let's do a demo. So to do this, these are the two QR codes if anybody wants to try it out. So this is basically Expo Go. You're gonna download Expo Go on your phone, and then I'm gonna show another QR code which basically gonna start the application. You can tell me when you've downloaded it. It's quite big. It's about 300 megabytes. Dobro, imate tehnički poteškoти s live streamom. Ne. You don't need accounts. Just open the application. And Mislim дека повеќето користите iOS, така да само камера апликацијата ви треба да отворите на Android има scan QR копче. Okay. Да, ќе зголемам само да се уклучи. Дали е доволно голем QR код? Open the camera app. Okay, so this is all native. What you're seeing is basically... Не се отварам, имам лаг на интернет. Не е проблемот до демото. До интернетот, да. Го немам пробано со волку корисници. Да, можете иначе и на 3G да го пробате, не. Ќе видиме дали лаптопот ќе ми издржи. Може? Да, не, у Expo Go ќе ви... Сата reload можем да ви пуштам мануелен. Немам пробано со толку луѓе, така да не знам ако сата кај од тука ќе пробам, не сум сигурен. In simplified terms треба да работи, не знам. Да, bundle, да, тоа е. Да. Ще локално ќе пробаме да видиме дали работи, не знам. Не работи ни локално. Можно е да е тоа проблемот, да. Ако сега можеме 3G да пробам да се конектирам на лаптопот, би сменило тоа нешто или може да се изгаси вјуто на лайвстримот? Чекај само локално ќе пробам. Да, ја ви изгасив. Чекај само локално, ај демо вака ќе направим. Чекај вака да пробаме. Без тунел. Океј, дур дебагираме демо дали имаме прашања. Надам ке. Океј, еве basically апликацијата што сакав да ја покажам. Okay, so this is the demo that I wanted to show. So on the simulator right now, it's not going to do anything. So basically, when you move the map, there would be a vibration. It's nothing special. It's just on iOS, it would load Apple Maps. On Android, it would load Google Maps. There is just a map with a pin. There is also the information about the current meetup that we're having, a more info link, which basically opens the LinkedIn link, and a modal, which on iOS looks like this, and some pictures, basically a list. That's about it, who I am. So what I wanted to show with this is not that one. Okay, this one. So basically, what OTA updates do is you can change the bundle of an application. So that means all of the logic on the JS side, it can be replaced. So companies mostly use this to force hotfixes. So if you ship some bug with an actual update and it's mostly on the JS thread, you can basically replace the whole bundle, which would mean you can force an update to every user. So there is no, separating if somebody gets the update or doesn't get the update. And you can basically go through, without going through the App Store, you can publish an update. That is what an OTA update is. This is in dev mode, so it works similarly, but not, in production, you would need basically a server to do this. So basically what I wanted to do is disable the haptic feedback, which we cannot really see right now, which would not cause the map when you move it to have any haptic feedback. That was the demo. I'm sorry it didn't work out as I intended, but yeah. Okay, the last section is, do you have any questions?
Okay, so I have two questions mainly. One is for the over-the-air updates.
Okay.
What's the extent of the update that can be published? Can
Okay,
we do
the
everything there, or is it just some
The
small
extent
fixes?
is the the JavaScript logic. So you cannot replace any native code, as you cannot ship a native binary over the air. But anything in the JS side, you can basically, if you don't have any custom native code, right, that you updated, you can basically replace all of your application through the air.
So
That would result in a ban from Apple. Yeah.
that was what I was gonna ask. Well, how does Apple handle this? Because they usually want to have
Apple doesn't really handle this because it's not illegal to do this. But primarily companies use this to, as I said, maybe you have a typo somewhere, like in an update you shipped, you have a typo in some text, right?
Can you get caught? For example, let's say I do an app that, I don't know, it's a pizza ordering app, and then I ship an update, and now it's an illegal streaming site for football games.
Yeah, you would get banned.
How?
They would see that it's not.
That's what I'm asking. Like, would you need to be reported by users? Does Apple check your
Yeah.
app?
The
from
users
time?
are gonna basically report the app that if you have a pizza app and then it's a illegal streaming application,
Yeah. And
Yeah.
then last questions unrelated to the previous two is that so recently when I was kind of looking at the iOS job market, I'd say 90% of applications are for native developers, and then there was a good amount of applications for Flutter, and there was a really small amount of applications for React Native.
Okay.
So if I am, I don't know, a new developer today starting to learn things, why, if I want to go multi-platform, why would I go with React Native and not Flutter? And then
Okay, so React Native is actually native. I don't know, Flutter is not basically native. Like Flutter, I don't know if they changed it, but the underlying architecture of Flutter is something like Unity. Like it doesn't have accessibility. Screen readers don't work in Flutter apps. I haven't seen any Flutter production applications as well. There are some. I think something like Google has made some of them. I think some demos, but yeah, Flutter is on an architectural level not native. I don't know if they change it in new versions, but yeah.
Yeah, I don't have a lot of info on Flutter as well, but I was just surprised to see a lot more Flutter developers wanted than React Native developers.
Yeah.
Because the way you presented it, it seems like React Native would be a much better option, but for some reason the industry kind of skews towards Flutter currently.
I think it's because Flutter, basically the code looks more native. Like it's quite similar when you write Flutter to something like Swift UI or Jetpack Compose. It's the code looks similar, but it's not actually native. So yeah.
Thank you.
I don't know why I would use Flutter.
Okay, so I have hard time to understand the process when publishing those JS changes. What server you are using, because they are not going through the App Store?
So I quickly glossed over this. Expo has a paid service basically, so you can roll your own service. You can have it on your own server, and basically you can have a hook when you open the app. Does it have a new version? Download the JS bundle, or you can have a background task that periodically checks if there's a new bundle. All of those things are possible, but there was something primarily called Code Push, which was by Microsoft, which now they moved to the App Center with Azure and everything. So those are the two primary, if you want something out of the box, either Expo updates or Code Push from Microsoft. Yeah.
So you're configuring the front-end application with that URL, so it will know from where to pull this code.
So there's a package basically. So there's the actual service that provides the holding of the JS bundle, and there is a package on the JS site which basically checks from the Expo is an Expo package, which basically you don't need to even set up. You just install it and it works out of the box. And if you roll an update, it would automatically check. Yeah.
Okay, thank you. Yes, that's all. A nice approach.
I think in the past there was an issue with the sizes of the application, like the size of the application, even for like a simplest application, was pretty big. Has that improved, or?
Yeah, the engine Hermes basically has made it smaller. So I think around 60 megabytes is some simple application. It basically depends on how many packages you use. So
Do you know like what is like the starting size of the application? Just I don't have any code, any packages, anything. Just
from my testing,
blank screen.
It's basically there is with Expo you can get something like dev clients, which are primarily used in development. But a production application can vary from something like 40 megabytes to something like 200. So it depends on what you're using. But something simple, it should be around 40 megabytes.
Yeah, I think that that's too much, if you ask me. Still gonna stay away.
That's fine. Anything else?
Thank you.
Thank you, everyone. And round of applause for Sebastian.